Hey, what's up, everybody? Today we will be looking at solving exponential equations. So for those of you who are taking this course just for fun and don't need a grade 12, then this will be the extent that you will kind of learn about exponentials. But I'm assuming you're taking this course because you really want to take grade 12 math, and you will deal with exponentials a lot more. And solving them is going to be important just in the sense of practicing how we move between, or sorry, not move, how we manipulate these exponential equations. And again, the way we manipulate them is using the exponent rules that we looked at in the first two lessons of the exponential unit, which was just exponent rules and then the rational exponent. Okay, so here what we'll do is we will look at how we solve exponential equations. So if you look at these two down here, these are super simple that most of you will know the answer to right away. So I have 5 to the power of x equals 25, and 3 to the power of x equals 81. So before we get into just solving it, just when we think about like how are these equations different? Okay, so really the main thing, remember when we solved like a linear equation, right? Linears are pretty easy. Like I have 3x minus 1 equals 10 or something like that, right? Here, like I solve for x. How do I do that? I move this across and then I divide. So like the essential, like the operations that I need to use to isolate for x is I either add, I subtract, I multiply, or I divide. Okay. And then when we solve quadratics, right? So same kind of deal. I mean, like, I don't know, like this equation here, right? Like we still utilize these, but here we also look for specific patterns that help us out, right? And if we can't solve this using patterns that we can manipulate like with our minds, then we can use the quadratic formula, right, to solve. Here with exponentials, the main kind of difference fundamentally to the equation is that the variable is in the, or sorry, I'll use a different language. The variable is the exponent, right? So if I look at my two equations here, right, I'm solving for a variable that is in the exponent, which is like which may seem kind of to the untrained eye, kind of like whatever, man, who cares? Like, what's the big deal? But it fundamentally changes how we deal with like the algebra with solving it, okay? Because last time I checked, like if you look, if the x is in the exponent, how the heck, like, how do I get it out of there? Is there a way to get it out of there? Like what's the algebra that I can use to solve for something that's an exponent? You've never done that before, okay? So essentially what we're going to do is we are going to utilize our knowledge of all the rules that we have come to know and how I manipulate these equations, and hopefully they are not too bad. Okay, so generally what we want to do is say, okay, well, okay, say 5 to the x equals, well, can I write 25 as base 5? Well, obviously, right? Like these two equations are true. So once I've written both sides of my equations, right, with the same base, what I can do is now I can just equate their exponents. Okay, so I can kind of almost ignore the 5. All right, and then I can say, well, what do I have? Well, I have x equals 2, and it's like, wow, great. Like we knew that. We knew the answer was 2. Okay, so I can do the same thing for this one here. Right, if I have 3 to the x equals, well, can I write 81 as a base 3? Well, yeah, 3 cubed. And then again, once I have this same basis here, okay, the bases now are kind of irrelevant, and now I just want to look at their exponents. And then I say, well, the answer, x equals 3. All right. So that is the fundamental kind of idea in how we are going to solve our exponential equations, right? We are going to first, right, make the bases the same. Right, and then we will equate their exponents. All right, so let's try another one. So same kind of deal. I have 3 to the power of 2x equals 81. So now here, now obviously, like now I have something different in my exponent, but I can treat it the same way. Well, this is just 3 to the 2x equals, well, 81 I can write as 3 cubed, right? Oh, wait, sorry, did I just, hold on. My bad. I think I made a mistake. This is 3 to the power 4, so my answer here should be 4. So if you got that, and we're thinking I'm insane, I'm not insane, but I did screw it up. So my exponent now is 4, and then once I have the same base, right, 3 and 3, I can kind of ignore the bases now, and then I just equate the exponent. So I have 2x equals 4. Well, obviously this is now just a simple linear one. X equals 2, and that is all. Okay. So again, hopefully these aren't too bad. Obviously, we will start changing them up where now, in order, like, not only do I have to, change the bases, right? But now we are going to use exponent rules to manipulate the equations. Okay? Because really, these first 3 examples, we haven't done that at all. It's just been kind of change the base is the same, make their exponents equal. Okay, so here is one where I'm going to do that. So notice now, again, if we kind of just sit back and just chill and look at the exponents now, like look what's happening. I can get more weird stuff in my exponent, right? Not just like a simple number. So here, so again, this is 5. Now this is a fraction. So what you should be thinking is, well, okay, fractions, right? If I have something written as a fraction, what exponent rule does that deal with? That's usually the negative exponent rule. Okay, so watch what I'm going to do. So now this side here, I'm going to leave because base 5 is good to me, right? I like that. 2x minus 1 equals. Now this I can write as 125 to the power of negative 1. Okay? Everybody cool with that? So now, what I want to do when I look at this, you're like, well, which side am I going to change the base on? And you're like, well, okay, obviously, like, what's the base? The common base is going to be 5, because this one I cannot change at all. Like this, I have base 5. This one, 125. Hopefully, when you think about it, you're like, well, 125. I mean, looks like it's going to be a multiple, or I'm going to be able to write it as a base 5, which you can. So what I'm going to have is I'm going to have 5 to the power of 2x minus 1 equals, and then this I'm going to change. So the 125 is going to be 5 cubed, but this is all to the power of negative 1, okay? So again, this negative 1 up here. So now, here, what can I, well, this, I can use the power of a power rule or a power rule, right? This will just be 5 to the negative 3. So now, base 5, what can I do? I can equate their exponents. So now I'm going to have 2x minus 1 equals negative 3. Now, just when you think about this is a linear equation, okay? Can you solve a linear equation? Obviously. So we're not dealing with some equations that you haven't seen before. However, when we solve exponential equations, we use the exponent rules to kind of change it so I'm dealing with bases that are the same, right? And then depending on what's in my exponent, now here I'm dealing with, like, this equation here is a grade 9 equation, but I need to solve it once I've done the grade 11 work, which is all this stuff here. All right. So I'll move the negative 1 across. I get negative 3 plus 1. 2x equals negative 2. Divide both sides by 2. And x is equal to negative 1. That is my answer. Okay? So hopefully that's all right. Now, obviously, if you can kind of, if your ability to predict the future is as good as mine, you can see that, well, if I've done all this and I've solved the linear equation, perhaps that means that I'm in the future can do a question like this where I'm left here with a quadratic, right? All right, so now let's look at this one. So the one rule we haven't talked about yet is, remember when we deal with rational exponents, right? Now, so remember if I had x, like the square root of x can be written as x to the 1/2, okay? So that's what we're going to do here. So here I have 36. Here I have this root of 1296 to the power of x, okay? So now 36 is a perfect square, all right? So normally when you look, if 36 is a perfect square, now I have this big number here, which, I mean, you don't, like, how do I say this? Like, off the top of your head, that number may look like it has nothing in relation to 36, but I would, whenever we deal with big numbers, right? If I'm dealing with big numbers, right, just check to see if it's a perfect square, okay? So for example, like here, the lowest, like if I have 36, why did I write 33? If I have 36, right? 1296, like, wouldn't it be convenient if this was 36 to the power of something? And then if I just take out my calculator for a sec, and then I go, well, let's try 36 squared. And then you're like, holy crap, oh my gosh. So this is actually 36 squared, okay? Which is good, which means I can change this base. So what we're going to do is we're going to change the base of this, but then also I'm going to rewrite this root with the appropriate fraction in the exponent, okay? So we have this equals, all right, so I'm going to change 1296. So that is going to be, right, 36 squared, right, to the power of x. And then this root becomes an exponent of 1/2. Okay. So if you remember, when we did some of that work for rational exponents, we had like, see how I have like this exponent, this one, this one? Like what I'm going to do is just use the power rule to simplify those exponents. So literally, what's the power rule? I just multiply them all. All right. So this side is still chilling. 2x plus 4 is my exponent equals 36. Well, like what does this become? 2x times a half, right? So 2x over 2, right? Which can be simplified to just 36x, okay? So now once I do this, right, I have my common base of 36, right? Now I can just equate their exponents. 2x plus 4 equals x. And then I will have x equals minus 4. And that is my answer. Okay. So again, this one does look a little weirder. But again, this to get the answer, this part here is just grade 9 stuff, right? But like manipulating this, changing its form using exponent rules, right? All this stuff here, that is the new concept that we are doing, okay? So let's move along. Hopefully everyone's doing all right. Everyone's doing okay? Anyone need to go to the bathroom? No? All right, so now let's do some ones that are a bit more challenging. So here, I have introduced the dreaded quadratic into my exponent, okay? So here, this is quadratic, which means that when I solve it, I'm going to be solving a quadratic. But again, it's no big deal. I mean, you're in grade 11, quadratics shouldn't be too scary. All right, so here we're going to have, okay, so I have 2x squared plus 2x equals 2 to the negative 1. All right, so again, this, I use the negative exponent rule. And then now, well, okay, this is easy. Like I have common base. So now I can just equate their exponents. So I have x squared plus 2x equals minus 1, okay? So now just remember, when I solve for exponents, when I solve for a quadratic, right, I can't solve it in this way. Like I'm going to take this minus 1, I got to throw it across, because I solve quadratics when the entire equation is equal to 0, okay? And then here I say, well, what two numbers add to 1, add to 2 and multiply to 1? Well, that's just x plus 1 and x plus 1 equals 0, which is just x plus 1 squared equals 0. So here my answer, x is negative 1, is my final answer. All right. So you need to prepare yourself for solving something in the exponent that is a quadratic or linear. All right. So hopefully that is not too bad. Okay, now we are going to hit, so these ones where we're solving, these ones would be considered like a thinking style questions, because these are a little bit more messed up, okay? Not that you don't think in all your questions, but these ones require a high level of power in your exponential rule use, right? So you have to be pretty well versed in that and manipulating the equations. Okay, so here I have an equation for the first time. Check it out. I have like two terms on one side and a number on the other. Okay, like I feel like here, just something equals something, something equals something, something equals something. Like just one thing equals one thing. When I go here, I have two things equals 12. Okay, so that's a weird thing, right? We have a, we have a subtraction of base 2's, which is kind of weird. And what's the other weird thing? Well, okay, this, this 12, right? 12, can I write 2 to the power of some nice numbers 12? No, this is, the human mind can't answer this. Okay. Or maybe some will, but weird, you have to be literally a genius, I suppose, right? Because for example, if I have, we can estimate, right? 2 to the x equals 16. Or we can say 2 to the power of 4 equals 16, right? Okay, cool. And then 2 to the power of 3 is 8, right? So we know our answer, I could write 12 as somewhere in between 4 and 3, but that, again, computers can do that. And algorithms can do that, but we can't. So that's also a weird thing, because this whole solving equation thing has been based on the fact that, like I said, change the base so that they're the same. If I can't make 12 a base 2, then that means there must be a different way I can approach this question. Okay? And there is. So generally speaking, when I look at this thing is squared. Now, that is a good thing. So watch how I'm going to write this. I'm going to write this as 2 to the power of x squared minus 2 to the power of x equals 12. Okay? Now, what I'm going to do, I'm actually going to move this across. Because if you've been pondering kind of what I just said, if this thing is squared, well, check it out. This whole equation, right? This is quadratic, right? Where the variable is replaced with 2 to the x. I'm sorry, the x is kind of weird. Okay, so what am I saying? Well, check it out. If I let, I don't know, let's pick a letter. Everyone pick your favorite letter. 1, 2, 3, go. I'm going to say A equals 2 to the x. Then if I replace 2 to the x with A, I'm going to have A squared minus A minus 12 equals 0. Okay, everybody with me? Now this, if you look at that, you're like, yo, this is a joke to solve. This is really easy, right? This is a simple trinomial, right? What adds to -1 and multiplies to 12? Well, -4 and 3. And then now what I'm going to do is I'm going to put back in 2 to the x. So I have 2 to the x minus 4. And then I have 2 to the x plus 3. And then now I have two equations which I can solve each binomial by itself. Okay? So what I'm going to do is I'm going to say, okay, well, this one, 2 to the x minus 4 equals 0. Well, this one's easy. 2 to the x equals 4. 2 to the x is just 2 squared. So here we know the answer is, one answer is x equals 2. Okay? Now I'm going to do the same thing for this one. 2 to the x plus 3 equals 0. 2 to the x equals minus 3. And then now you look at this and you say, okay, well, like, what's the problem? Okay, if we just roll out the squares for a second, like 2 to the power of 1 is, or sorry, 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 squared is 4. 2 cubed is 8. 2 to the 4 is 16. Like, where is negative 3? Oh God, it's ugly question mark, right? Where is it? It's not there. Yeah, it's not there because you can never find an x that will make this equation true. And again, if you think about the basic graph of, like, I'll just draw an ugly 2 to the x. This is a graph of 2 to the x. And then where is minus 3? Well, minus 3 is down here. This is the line y equals minus 3. Will this graph ever hit this line? Never. Okay, so this one is unsolvable, right? Or DNE, which means does not exist. Okay, so the only answer is x equals 2. All right. So again, these ones are a little bit more thinking style questions because you're manipulating more of the initial equation than manipulating the bases. So like it's a little bit more challenging. Okay. So let's try another one. So let's see, how do we deal with this one? Well, similar. So I have, okay, 25 to the power of x minus 35 to the x plus 125 equals 0. So again, when I look at, I have 25 as a base, I have 5, and then I got this 125 here. All right. So, like, what I can do is I can change the first term to this, right? All right, everybody cool with that? And then this, what I can do, like, see how this is squared just like this one is squared, right? It's just that these are swapped, right? So like this I can write as that. Okay, so notice what I've done. What I literally have modeled this so that just like the last example, this here, right? This is a quadratic that is hiding in the form of an exponential. Okay. So now here, if I let, right, so let b equal 5 to the x. So what do I get? I get now an equation, b squared minus 30b plus 125 equals 0. Okay? Everybody cool with that? So now this is a quadratic that we can see, right? It's not hiding, and we can solve, hopefully, right? So we say, okay, well, what are the, like, what adds to negative 30 and multiplies to 125? Well, if you think about it, 25 and 5 multiplied to 125, and they would both have to be negative. So b minus 5, b minus 25 equals 0. Okay, and notice here, like, you're given ones like where you can solve this, like again, I've said this before, for students who are going to take IB next year, and you have questions that don't require you to use a calculator. Like, this is one perfect one. You don't need a calculator to solve this at all. Okay. So now what do? I replace b with 2 to the x. or sorry, not 2 to the x, sorry. So 5 to the x, 5 to the x, minus 5, minus 25, okay? And then I'm going to solve it just like I did before, right? So now we will solve one binomial. So 5 to the power of x minus 5 equals 0. Well, that's just 5x equals 5. X is 1. And in this one, just as easy. 5 to the x equals 25. 5 to the x equals 5 squared. Therefore, x equals 2. Okay? So those are my two answers. All right? So what I'll do, so there's one more left that I'm going to ask you to try on your own. So that is this one. So try this one. I will post a video with the solution to this one. Video or PDF. I think I have a PDF of the solution, but if not, I'll post a video. So try that one. Okay, very similar in not exactly the same, but similar to these ones. Okay, and then your homework. So this will be a file that will be posted in the classroom. Again, these ones here are all kind of like general knowledge using exponent rules to help write the same bases. Don't do these ones here. This one here, don't do. Okay. And then the last set of questions, these ones here are all, these are all like thinking questions, okay? So like the last 2 or 3 that we did together, okay, where you have to try to like change the base, but the equations are like quadratic or not. So like do a few of these. If you want to do them all, do them all. And then obviously if you're having trouble with any of them, let me know and I can post a solution. But again, make sure like attempting these is good. You may struggle through some of these, right? Struggling, there's nothing wrong with that. Just persevere and work hard. And some of these you should be able to get. All right. And like I said, I'll post a solution to this one, right? Once I give you guys a little bit of time to try it. And then I will post the next lesson, which will be properties of exponential functions. So that's kind of a little bit of graphing, but most of that will be on Desmos. So it'll be less homework, but hopefully easier for you to do. Okay? All right. Hope everyone's good. Take it easy. Enjoyed the weather, but don't hang out in large groups, man. Okay, I saw a crazy amount of kids like at like a skateboard park by my house. Must have been 50, just like hanging out, you know. I guess I mean, I get it. You're young and you're like immortal, right? But and you don't think you can spread a disease. But just stay safe and watch Netflix. Okay, see ya. Bye.